Hello, welcome back to my channel Hyderabad. In this video, we are going to see a hands-on coding on polynomial regression, and we are also going to see what exactly is polynomial regression. I believe most of you guys are following this consistently, specifically this playlist, and I have seen so many comments saying, ma'am, I completed today's work, I completed day 50, day 51, day 53. So if you completed the session until the end, make sure you go and comment below I completed today's session because consistency is the key. Only using consistently you can achieve your goal. Yes, let's get started. So in today's session, let's try to understand what is polynomial regression on first. So this is how generally polynomial regression curve will look like. So just by looking into this, what you can understand. One thing that you could understand is it is something different from linear regression and multiple linear regression, right? But what is the difference? The curve. Linear regression and multiple linear regression, you might have seen something that is a straight line, which says if my value of a feature get increased, the value of a target variable will also get increased when it comes to linear regression. But in polynomial regression, this is not the same. There are chances that value in feature might get increased, but the value of the target variable might get decreased sometimes. The values might not be consistently rising. There are chances it might decrease, and there are chances it might increase. That is how the real world data will look like, right? So that is how it is going to be messy, right? So for real world data, specifically for solving all kind of problems, polynomial regression is going to be as a go-to algorithm. So this is how generally the curved line, the graph that we are going to plot will definitely look like. Absolutely, it's not going to be a straight line. It is going to be a curve like one curve or two curve or something. It's curvy, but so for today's session, the dataset that we are going to work with is MPG dataset. So MPG means miles per gallon. So here the problem statement is predicting the fuel efficiency MPG of a car based on its weight. The dataset that we are going to use is automatic MPG dataset that is available there on C1 library. You need not import something and upload here on the folder part. Instead, you will just import it by using this piece of code, directly importing it from the C1 library. Before that, the first important step is importing libraries. NumPy for numerical computations, Pandas for table handling, Matplotlib and Seaborn for creating visualizations. Then I'm importing train test split for training and testing my dataset. Then polynomial features. This is the key library here. This is used for importing and using polynomial regression into linear regression. So then I'm importing linear regression, and finally the evaluation metrics, mean squared error and R-square score is being imported here. The second step is loading dataset into my coding environment. This is how I'm importing my dataset. So here what I'm doing is I'm creating a variable name called mpg, which is equal to sns.load dataset. Inside this I'm giving mpg. This is the dataset I'm going to load from Zpon library. And then I'm giving mpg.head to see my first 5 rows. So see, these are all the columns that I do have in my data set. Next to that, I'm trying to understand my data set. For that, the first step is try to understand what kind of data types that I do have in each and every column. So just by giving mpg.info, I can clearly see to which data type each and every columns in my data set belongs to. mpg is a float column. See, we have float values. Cylinders are integer column. And displacement comes under float column. Horsepower comes under float column. Weight comes under integer column. Acceleration comes under float column. Model year comes under integer column. And absolutely the origin name comes under object column because it is going to be a string like this. The origin might be any USA or anything like that. And name might be the name of the model. And to see the statistical summary of every numerical column. So what is the step that I'll be using? Dot describe. Here mpg dot describe. So just by giving this, I can see every numerical column's minimum value, maximum value, 25%, 50% and 75% values. And I can also see the count of all values, standard deviation and every value is related to it. The fourth step is data cleaning. So in this step, what I'll be doing is, I'll be finding sum of all null values in my given data set. This is the essential step. As this is quite a data set which is often used by students for learning, this has very less number of null values. Only in Haas column, I just have 6 null values. So the best solution for dealing this is dropping that particular null values, the particular rows which has null values. So that's why I'm giving mpg.drop now. The following step I'm going to see is duplicates. So in this step, I'm going to check if it has null duplicates, and if it has duplicates, it will be getting dropped. So that is why I'm giving mpg.drop duplicates. And the next step is reset index. So this is specifically used for, I'm giving mpg.shape, right? So in this particular step, what I'm doing is, after doing all these steps, the data should be stored inside mpg after all these steps. That is what I'm giving here. So after giving mpg.shape, it will be showing my number of rows and columns, followed by that EDA. So this is a step for understanding my data actually. So what I'll be doing is, I'll be creating visualizations to understand my data in a better way. So look into this coding part. What I'm doing is, I'm giving plot.figure to create an empty space where I could plot my graph. Then I'm giving dot scatter of 2 columns for which I'm going to plot. So what I'm going to plot a graph is, for which columns I'm going to plot a graph is, for weight of a car and the MPG. Based on weight, how the MPG differs. Miles per gallon differs. It is almost similar to mileage. So followed by that, what I am giving is, I am giving customized X labels, Y labels and titles for this particular chart. And finally, when I give plot.show, it will be creating my chart and showing like this. The next step that I'm going to do is creating a correlation heat map. So for this step, what I'm going to do is, first I'll be giving plot.figure. So it will be creating a figure space like this, and then I'll be giving sns.heatmap, inside which I'm giving mpg.correlation. So it will be creating a correlation heat map like this. And when I give numeric only is equal to true, so all the numerical values, the columns which have numerical values will be taken into consideration. Followed by that, I'm giving plt.title. So the title of the chart will be given like this, correlation matrix. And finally, when I give plot.show, it will be showing the chart that I've created. The next step is feature selection. This is actually the first and foremost essential step that we need to do after understanding my data and doing exploratory data analysis. So in this step, what I'll be doing is, for predicting my target, what are all the essential features or the columns that I'm going to use. That is something that I need to decide. So for this particular problem statement, what is the column that I need? Absolutely the weight column. So this is the feature that I'm going to use for predicting the target, MPG. Next to that, I have train, test and split. So in this step, what I'm doing is, I'm giving 20% of data for testing and the remaining data for training. Followed by that, what I'm doing is, I need to build a polynomial regression model, right? For that, what step I'll be doing is, I'll be converting all the features to polynomial features. Followed by that, I'll be building a linear regression model. Now, this is how the actual polynomial regression model is being built in this particular problem statement. So, while doing the coding, do not make any mistakes even in single piece of syntax. If you miss any part of syntax, you might get errors. Even if you want screenshots or something, you could take it along with me. And then the predictions. For predicting how my model is working on the testing data, the 20% of testing data, I'm using the prediction step. Next to that, evaluation. So this is a step where I'll be getting values for my evaluation metrics that I imported, MSE and R-square score. So R-square score here, if values are almost close to 0.7, it says my model is performing good, right? So it's 0.67. It is almost performing definitely good. And finally, to see how my curve looks like, this is something that I'm doing. So I'm creating a chart and visualizing how my chart actually looks like. The polynomial regression fit that we discussed earlier, right? So it will be a curve. It will not be a straight line. So as similar to this curve, it is actually a curve and not a straight line at all. See how it looks like? It is a curve. It is partially a curve. It is absolutely not a straight line. So while doing coding, make sure in the syntax you are not making any mistakes. Yeah. So the one thing that you need to keep in mind is polynomial regression is specifically used for showing you the patterns, specifically the non-linear patterns that is hidden inside my data. So data cleaning is essential and very important when it comes to polynomial regression because this data is definitely messy. It is not actually a straight line. That is why we are using polynomial regression. If it is clean and give the data, the model might misunderstand. It might have the problem of overfitting. Instead of learning my data, it might memorize my data. I believe this session helped you in clearly understanding polynomial regression. And today's task is, here we created correlation heat map, right? So in this step, we do created correlation heat map. So after EDS in this step, before feature selection. So in this correlation heat map, you might have seen some insights. So you might have got some insights, right? How particularly this column is affecting my target column. Which column has high relationship with target column? This is something that I taught you in the previous video for that data set, right? So for this data set, after seeing this correlation heat map, what insights that you took? You should add this below this particular chart by adding a text box. So if you completed this task, come back to my video and comment completed the task for the day. Yeah, I believe the session helped you in clearly understanding polynomial regression, and I believe you will complete the task and make sure you comment below I completed the task for the day. Bye for now. We'll meet you in next amazing video.